Right, seems like it's working. Let's continue where we left off. Just bringing up my rig here, my studio. There we go. So what's next? I think it's making it infinite. That is next. So just gonna have to check the sound quickly here. Test, test. Test, test. Perfect. There we go. All right, so mission for today is make the world like expand as we go. I'm not sure how to do that with the type of mesh that we're working with. Ooh, since it's an array mesh now and not just boxes. With boxes, I managed to solve it. But now let's see with the array mesh. Does it have to be a rectangle or not? That's the question. Right, so how do we add? Let's make this smaller. Let's do like 8, Expecting a very small one now. Yeah, boom, okay. And then let's see if we can have this expand as we walk. So we need something in the process. Yeah, generate new cubes. Maybe. Cubes for. I think we can just do this thing. This is like multiplayer support now, but that's fine. Okay, I just need to fix the timing of my other computer here. It keeps going to sleep. I don't want that. Mac sleep timer. Energy saver. Battery. Okay, here. Let's do like 2 hours. 2 hours. Okay, that should be better. Let's actually see how this plays out. The frame rate might be terrible. Yeah, it is. But yeah, it actually looks like it's working. Impressive. I did not expect that. And here we should use our if new functionality. We're not using that at the moment. Package mesh. Do we keep the arrays as a global variables, or how does this even work? It's a mystery, honestly. But I think as long as we keep this as a... I'm not sure. And how do we edit? That's a problem for the future. Like, how do we change a variable? Like if we want to dig in the ground or something. Because now they're not in order. We're just adding stuff randomly. We don't have any pointers by position in the packed array. If not has cube been generated, then we do this. And then we do register cube generation at coordinate xc. This could work. I think this could potentially be enough. Because these are just storing coordinates. And we're already working with coordinates up here. Yeah, this works. Oh my god. How cool is that? Kind of excited to just keep exploring this world. Where does it go? Where does it lead? Wow. Okay. This works. Nice. Let's commit that. Down in the jungle. So we need the path. Right. Sandbox game. Git status. Git add. No, this is not changed. Git commit. Interesting, yeah. It's not case sensitive here. Isn't it on Linux? I think it is on Linux. I'm not entirely sure now. When searching, or like when tabbing through W, it just picked a small one and then the big one. Let's call it infinite. I know it's not infinite in theory. Infit. Infinite world generation now works. So what should we do next? There are like two options. Either refactor goes back in the backlog. Colors. Or the ability to, let's say, dig. To change, like to transform the shape of the land as a player. I think the dig mechanic will be super interesting to implement. But I'm also curious to see interactions. Design interactions with the landscape. What does that even mean? I wrote this. Make the... Okay, let's keep it. Maybe it's good in the future. If it's equally or less clear next time, I will probably delete it. I think I forgot what the thought behind it was. So, make it possible to dig in the ground and change the shape of it. I think that's going to be extremely hard to do with the current way that the code is working, because right now we have, so yeah, we're starting out with a grid where the player is standing in the middle, which is 8 by 8, for example. But as the player moves here, the grid will keep expanding, or like if he moves up here, it will move like that. And so in the beginning, we know how we generated this in the triangle array. Like every triangle in order, no, they're like this. It's gonna be, okay, so the first 3 vectors in the array are gonna belong to this let's zoom in a bit. First, second, or no, even better, let's do A. And then triangle B. And so the first vector is going to be this, second, third, or is it the other way around? Yeah, but it's going to be these. So if you want to find like whatever is on this position here, you have to go through like 1, 2, 3, 4, 5, 6, etc., etc., until you end up here. So you know exactly which vertices these are. But when we start moving around, the order is not gonna really be there. We can walk like this and then back here and fill in these. But these are gonna come into the array, like this one here might be at the end, while something down here in this regular order that should normally come after might be here. So how do we find them then? If not by position. Spatial material, vertex color. Vertex color. Oh wait, can we give them colors? for every vertex. How is that rendered? Let's try to do something about that in here. Func get vertex color y get color from noise. Okay, maybe we can just use get color from noise here. It's not going to be right now. But let's just try it anyway. So they're doing colors, pool color array. Can we do packed color array? I guess that's the new thing. Package mesh. Packed color array. Colors dot push back. Corner d dot y. Get color from noise. DBA. DCB. Package mesh. So this is gonna be C. Colors dot push back. Colors packed color array. Why can't I do that? Okay, this is not possible in this language. Maybe I can create the colors here instead. So let's do pushback. This is starting to become some pretty ugly programming here. v3 dot y. And here we'll give it vertices and colors. Colors. Let's see what happens. Right, get color from noise. Nothing. So what are we getting returned here? We are getting some different colors. So it doesn't necessarily work. Godot coloring. Same search. Array color. You're the inspiration to my life. The inspiration. Don't know how to hear me. Baby, baby. Mesh data tool. Helpful for dynamically altering geometry. Ah, provides more information and tools to work with meshes than the array mesh. Yeah, I need textures.
Here's a quick tutorial on something that took me way too long to figure out. I'm going to show you how to create this mesh with two separate textures on it. There's a link to this orange icon in the description below. So I have a scene here with the mesh instance as the root node with the script attached. In the script I have the vertices and UVs for the bottom left triangle of the square. In the scene view, click on the mesh in the mesh instance inspector and you can see this section called surface. Here's where you can add a texture or material. Now back in the script, I'll add the vertices and UVs of the triangle for the top right half of the square below the add surface from arrays call. I'm overwriting the existing data so the array only has the data for the second triangle. Then I'll call add surface from arrays again with the new data. Every time this is called, it adds to the existing mesh but does so with a new surface. Back in the scene, there are now two.
Hello everybody, today we are with another tutorial, and this time we'll take a look at mesh arrays and how we can use them to create meshes procedurally. So before I start, I want to remind everybody that the code you always going to see in my tutorials is going to be available through my GitLab repository. You don't have to do anything special. If you are familiar with GitHub, it works exactly the same. So you go here and you can either clone it using a Git SSH, or you can clone it through HTTPS. Again, the same thing with GitHub. And if you're not familiar with GitHub, it's not a problem. You can go here in this icon, click here, download zip file, click on the zip file, and it's going to pop up. It's going to pop up the dialog for you to download it on your hard drive. So today we're going to talk about the array mesh. The array mesh is used for creating meshes. It's the fastest method for creating procedural mesh. And we're going to see how to actually do that. So I'm going to fire up the tutorial. Let's see if is it opened? No, it's not open. So let me fire up the tutorial. Maybe put this up. As you can see, I have added a new tutorial, open. And you can see here, I'm creating a sphere, and I've added the main menu, which goes back to as the other scenes. The YouTube video, I have created a wireframe so we can see things on wireframe. I've added a radius and a height, which we're not going to use in this tutorial, but I think height doesn't really work. I don't know why, but it doesn't really matter for this tutorial. And there you can define the rings, which the rings is the horizontal lines, and segments is the vertical line. So you can go here and do a 10 by 10. And then you click generate sphere. And as you can see immediately,
cool.
It changes the shape. So let's see how this actually works. So the first thing you want to do, let me go back to Godot. You have to go back to the scene. Let me go back to the scene. Is this the scene open?
Okay, how do you give colors? It's the very first time in my life that I hear the letter theta being pronounced by an actual Greek. Thanks. Okay, let's look some more tutorials.
I don't know about you, but when I saw 2018 Game of the Year, The Legend of Zelda Breath of the Wild's grass beautifully rendered on a device that fits into my hands, the first thought that came to mind was, how can that be done in Godot? In this video, I'm going to go over everything you need to know about rendering dense and filling, draw distance, and other techniques to render dense fields.
Legend of Zelda Breath of the Wild using the Godot game engine.
Luckily, there are a few tools and handy plugins to help make beautiful patches of grass. The first tool I'm going to show you is Scatter. Scatter is a plugin made by Hungry Proton, linked in the description.
Hello everybody, today we are with another tutorial.
I like this guy, Killon. It's good stuff. First steps with voxel tools.
On days
I wanted to draw. Oh, nice. What are you drawing? Please share. But I got voice first. So are you okay?
Okay, maybe we should write texture instead.
So I have my main scene set up here with the spatial as the root node
Hmm.
and a directional light. Start out by adding a mesh instance and attach a script to it. Add tool at the top so this will run in the editor. And then close and reopen the scene to run the ready function. Whether you use an index array or not will depend on whether or not you want adjacent faces to show
Array
data like
index.
UVs or normals. Speaking of normals, the lighting on this is a little wonky. Normals tell light how to interact with the mesh. A normal is a directional vector and one exists at each vertex. That vertex will be part of a face, and the normal should be pointing in the direction that that face is facing. If the vertex is part of the vector, go down to surface, and then drag a texture onto the material property. You can see our texture is nicely fitted onto our square.
Hmm. Yeah.
I'm going to show you how to make this terrain. And eventually in another video, I'll show you how to make this. And sorry about the frame rate, I need to find a better screen recorder. There are links to this starting project and the finished project in the description below. For now, just ignore
Yes,
this folder
please.
name player. Start by adding a static body to the main scene. Click on the material, go to its inspector, expand the albedo, and change the color to something that isn't so harsh. That's called open simplex noise. It has a bunch of functions that take in coordinates and return a value ranging from negative to positive 1. Elements to new variables. In other words, replace the for loop with another
Yeah, he's doing
that
the same
iterates
thing
from
I'm doing
0
so
to
far.
the size of the vertex array and set them directly up as if it's still a flat plane. So how do we calculate proper normals? Changes to make playing around with this terrain more convenient. Export 3 variables named size, subdivide, and amplitude as well. If you want rocky terrain, increase the octaves and decrease the period. If you want something that looks like rolling hills, do the opposite.
Oh, that's
Now
cool.
stop ignoring this folder name player. Call create try. That's the sound of me hitting the spacebar with increasing anger because the player isn't responding by jumping a lot of the time.
Textures.
I'm
Slope
going to
and
show you how to
height.
make this terrain that displays 2 different textures depending on how steep it is. It also blends between those 2 textures and a third depending on the height.
Yeah.
This video will
please.
require you to already have a basic understanding of how shaders work. This is a terrain scene from a previous video. It lets you set different properties of the terrain and then regenerate the mesh. I've also imported 3 ugly textures. They're supposed to be grass, rock, and sand. I'll put a link to the starting project in the description below. Start by adding a shader material to the mesh. Do this using the material override under geometry, or else the material will be reset every time you generate the terrain. In the shader, give it a type spatial. Add a uniform sampler 2D for each texture, then drag each texture onto its respective slot in the shader params. Define a fragment function and add 2 vec3s that will contain the albedo values for each texture. Multiply the UV by 4 to make the textures appear smaller on the mesh. Since the Y value of the normal at each vertex on the mesh will be 1 if its face is totally flat and approach 0 as it gets steeper, we are going to use it to determine the weight in an interpolation between the grass and rock albedos. We are in the fragment function, so the normal will be in view space. To convert this to model space, put the normal variable in a vec4, Multiply that by the camera matrix. Then get the y value from the result. Or we can just declare a varying float and assign it the y value of the normal variable in the vertex function. In GLSL, the interpolation function is called mix. Since every face of our mesh is angled, it is covered by a blend of both textures. These faces also don't have slopes much greater than 45 degrees, so the y values are most
So there is some way to dynamically set the textures. But what is this
the
a script?
upper end of the 0 to 1 range, and the grass is much more predominant. Let's change this so anywhere on the mesh that is 45 degrees.
Oh, it's a
cheaper.
shader. Okay, I need to look at what a shader is, I think. This page. This page explains what shaders are and will give you an overview of how they work. Also, we draw everything with shaders. Shader code runs on each vertex or pixel in isolation. Cannot store data between frames. Ah, interesting. In GDScript, you use a for loop. Fragment, color. Oh, interesting. So yeah, he's doing some shade. Okay, I need to learn shaders. Interesting. Fragment function once or more for each pixel it has to draw. That's what he did here. Fragment. Processor functions. Fragment vertex. I thought 3D seemed surprisingly simple so far. But now we're getting into some interesting aspects of it. The start function runs for every particle. Process runs for every particle in a particle on each frame. Fog runs for every froxel in the volumetric fog froxel buffer. That intersects with the fog volume. Every froxel in the volumetric fog froxel buffer that intersects with the fog volume. Yeah, let's do some learning on shaders. Interesting. Interesting stuff. I think this is what's gonna enable the world to become really beautiful.
Ganska snart klart, så vi kan börja duka snart.
Soon time for dinner. This exposes an API for users to write totally custom GLSL shaders. This feels quite low level. Shaders in Godot. Oh, it's big shaders. Your first shader materials using visual shaders, compute shaders, screen reading shaders, shader style guide. Wow. Writing your first shader, it is intended for people who have very little prior experience. The Book of Shaders. It's a gentle step-by-step guide. Oh, look. Is this what we can do with shaders? Cool. That's a very cool illustration. The abstract and complex universe of fragment shaders, and with this image above it. It's pretty epic. Imagine the CPU. This is interesting, and it's also teaching about deeper computer science concepts, like why are GPUs popular? OpenGL shading language. do I need? I mean, shaders seem cool. That seems to be what's. I'm guessing a bit here, but like my interpretation is that this is probably the foundation of the engine. But is this really what I need right now? Probably not. Ooh, turn off the lights. All I want is some colors on this. Okay, I think that's gonna be for next session. I will close the stream now. Oh, the debugger. Wait a minute. What's going on here? Huh? Okay. Cool. I'll save it like that. Thank you so much for tuning in, and see you in the next one. May wake out. Bye bye.